Yo, what up? Is this thing on? Can you guys hear me? Yo, yo, yo. Mic check. 1, 2, 1, 2. All right, cool. Looks like the mic is working. All right, so welcome back. If you're returning, um, if not, welcome. So last time I was working on this, believe I was doing some OBS integration. We ran into a problem where trying to sync keystrokes to the Linux host is that's not gonna pan out because my Linux host is using Wayland, and Wayland is very grabby and picky with which window gets access to the global keyboard. In other words, there's no global keystrokes in Wayland. So if I have an active window, say I'm like working on this thing, and I decide to send a keystroke and hope that that keystroke gets to OBS, it's not going to make it unless I mouse over and make OBS the active window. So that's not super practical. So what I decided to do was hook up the OBS WebSocket library in Python and write a couple functions to do some basic functions within the OBS within OBS through the WebSocket. So I spent some time getting some boilerplate and basic functionality going within this OBS integration. We've got a couple different things that I'll go through and show you how these work here in a minute. But just the basics of what we're doing is we're starting off with getting a handle to OBS. So OBS has a WebSocket server. I believe it is under Tools. Yeah, there it is, WebSocket server settings. So you can go into OBS and configure OBS to have a WebSocket server running, and you can set the port, and it automatically generates a password for you that you can use. In our case, we've taken that password and we've stuck it into the environment variable. So you can see we're exporting OBS underscore WS, and that's our OBS WebSocket password. So we're exporting that into the variable, and that's how we're getting that within our Python code. So a little bit more secure. You're not like leaving that stuck in a file somewhere. But also it's still plain text, so whatever. I'm not too worried about it since this is going to be a locally hosted WebSocket server anyway. I'm not going to be opening this port up to the web or anything, so shouldn't be too worried about that. So we're getting our host port and password, and then we're passing that to our OBS WebSocket functions, connecting to the WebSocket, and then we're returning a handle. And if we don't get the handle, we print a failure. So once we've got that handle, we can then call these functions, like our get scene, switch scene, toggle input, and toggle source. I put these together because I want to have some functionality on this little display pad thing, so that if I push a button, I can say swap the scenes or toggle a scene or mute my mic or turn off and on a source within OBS. So I've gone through and implemented the basic function for that kind of activity. So our get scenes basically calls the get current program scene within the OBS WebSocket, and that will get a list of scenes and store it into our scenes variable, and then it'll also get the current scene, store that into our current scene variable. We've got our switch scene function, which just calls a WebSocket call to set current program scene, and then it sets it to the name that you specify. Our toggle input is pretty straightforward as well. It's a little bit more logic, but what we do is we go and we call get special inputs, and I ran into an issue, if anybody else is messing with this later, where the documentation that I was looking at was out of date. But this right here under OBS project, OBS WebSocket, has the basically up-to-date description of the protocol. So this has been very useful for implementing these WebSocket commands. So just for anybody in the future who runs into that same problem. Get special inputs. I think it was called get device inputs or something like that prior, and they renamed it. So I ran into that as an issue, but that's not a big deal. We just rename it and then call get special inputs. So we do that and we store that into our inputs variable. Then we also set up a response variable, and then what we'll do is we'll iterate through our inputs, and we'll try to get the input name. If there is no input name, then we return a string of none. And then if our input name is the same as the name that is passed to the function, then we call the toggle input mute, and we pass the name to that. That way we can specify, we probably need to move this to, we could probably move this to like the setup or something. Yeah, we can do something like that. That way we like prefix this this value. We don't have to call it every time we toggle our input. That'll save some help, or save some cycles. Let's see. So then we toggle our input. We toggle the mute for it, and then we return the response. The response will return whether or not the input is muted. So we can handle that with a little bit of extra logic later in our code. For example, I wanted to set it up so that the microphone button, if you go into like the config and you specify OBS CMD toggle input microphone, like you want to mute the microphone, what we can do is we can check the state of this when it gets returned from the OBS CMD, and if it's muted, we can change the color of the button or something like that, or change it to a different image. And that way we know visually when looking at the device that, hey, we're muted, or hey, we're not muted. So that'll provide some feedback for us. And then our next function is the toggle source function. This one goes through and it gets the current scene out of our current scene variable. And then it goes and it calls the get scene item list, which gets the items that are in the scene, which are going to be like our sources and stuff. And so it passes the current scene name, and then it puts all of that into our sources variable. And then we also go through and change our sources variable to the scene items. So the value that it passes back is nested within a scene items, or the values that we're interested in are nested within a scene items dictionary. So we're just going to go and pull that out, and then we're going to iterate through all of the sources. We go and set up our request variable again, or sorry, our response variable, and then we go through and we check to see if the source name matches our name that we're passing to the function. And if it does, we will first what we do is we check to see if the source is enabled, and then we will get the item ID, get the scene item ID, because that's necessary to actually toggle the scene item. So if our scene is enabled, we set the state to false. If it's not enabled, we set the state to true. And so this is kind of like a flip-flop logic. And then we'll pass those values to our set scene item enabled WebSocket request. So you can see we're sending the current scene, the item ID, and then the state. So just to kind of demonstrate this a little bit, let's see. So go ahead and run this OBS integration, and then let's see, actually it's probably a bit easier. So you can see it's toggling the source color. This is kind of a demo OBS that I set up. So down here, last thing I was testing was the toggle source. So what it'll do is when this first runs, it'll go through and toggle the source on OBS. So if I have both of these open at the same time, you can see it go through and turn that source off, kind of hide it. And then if we run it again, it'll unhide it. So we've got some code that's talking to OBS, which is pretty cool. So now what we'll need to do is integrate this into our DisplayPad worker code, and then also our panel code. So I've already kind of gotten started on that. What I've kind of got going on in my brain for this is to have a generic OBS CMD action, and then the value gets split into the actual action parameters, or the action and the action parameters. So for example, in our OBS JSON config, we're specifying for button number 4, we're going to do an OBS CMD, and what we're going to do is we're going to toggle the input, and this is the input that we're going to toggle. So back in our display pad, our panel code, what we're doing with this is we are splitting it on the space, and the left value is going to be the command, and the right value is going to be parameters. That might be problematic if the length of this array after being split is more than 2 items, but I don't know if I want to bother writing some test cases to deal with that right away. So let's see. So we're splitting out our command, and what I want to do is call our OBS integration. So let's make sure that we're actually importing this. Import the OBS integration, and then I also want to come down here and take out this stuff. I'm just going to comment it out for now. And comment this out. And if you guys have any questions while I'm going through this, or if I talk too fast, or if you want me to kind of expand on something a little bit more, just throw it out in the chat, and we can dig into it. All right, so back under our panel, we're importing our OBS integration. And then what we'll need to do is I think what we want to do is we don't want to make the I don't want to run into an issue where, like, say you don't use the OBS integration. So maybe we want to go through and check when we first start up our code, our worker, and it goes and it loads up the panels. When it goes and checks the configs, we should check for any OBS CMD, the presence of any OBS CMD actions, and if those exist, then we should set up the handle. So what we can do over here is under panel. So we're setting up the panel config right here, loading the panel config. So this is our config JSON. There's our key mapping. So what we can do here is for, let's see, kn self.key mapping. So that's going to be the key mappings dictionary. So we want to iterate through this and check to see if any of the actions are OBS CMD. So that is going to be, how do I want to do that? Let's see. All right, let's initialize our has OBS CMD. And then what we can do is for k and key mappings, if k.get action OBS CMD in k.action, then we do has OBS CMD equals true. And then what we want to do is check over here. If has OBS CMD, then we go through and we do OBS self.obs handle equals then we just instantiate an OBS handler. And that'll have a, okay. I think that should work. Let's just do that for now. OBS handler. All right, so self OBS handler. Oops, did I just close out of that? I do that all the damn time. Okay. So we're setting up our OBS handler, and then what we can do is down here, we can do OBS self.obs handler dot, and then what do we want to do? Oh, we need to check to see if the command, so if cmd, or let's see, so we got switch scene, toggle input. What else do we want? Got switch scene, toggle input, toggle source. Okay, let's just do those for now. And as we expand this, we can come out and add some more commands into it. Let's see. So if toggle input in params. All right, sorry, in CMD. Oops. LF, and then what was the other one? Toggle source or switch scene. Toggle input, toggle source, and switch scene. Toggle input, toggle source, switch scene. And we could probably do this a little bit more programmatically. Let's see, toggle sourced. Probably do this a bit more programmatically if we reference our object and get the the methods off of it. And then we can just call those methods. That seems a little annoying. So we'll just manually do it. All right, so let's go ahead and set up our, actually I want to move this just because it bothers me. Oops. Oh, good God. There we go. All right, so then we have the toggles next to each other. Toggle input, toggle source, switch scene. So what do we want to do with this? So what we want to do is call our self OBS handler, and then we call the toggle input, right? Toggle input, and then we pass it a name. And then that's just going to be params. I'm going to copy a lot of this because it's going to be very similar. But we may also need to do some stuff in the future for each case, depending on what kind of data we're putting into the config, like if we get real fancy with it. Switch scene. OBS handler, switch scene. Yeah, it looks ugly. I don't like coding AI. Doing a bunch of if else then statements. Especially if you're just doing the same thing. I don't know, it makes me feel bad. Yeah, but okay, that should work. Switch scene, pass the params, toggle source, okay. And what that should do is it should take this right here, this value, switch underscore scene space scene 1, and then what it'll do is it'll pass it to this switch scene function and give it the name. So that should work. That also means that if we're making a handle to OBS for each, that would be a handle for each panel. If I'm setting up the handle for OBS up here. So we might need to do this in the actual display pad worker. I think that's probably a better spot for that logic, is to take this. And then put it over here in the worker. Because we could do that all up here, yeah. See, look, I even already put it right here, get OBS handle. Man. All right, so the logic of checking to see if we have an OBS CMD in our key mapping should be good. What we want to do is we want to iterate through our panel list and then do the same thing. Okay, so for pn panel list, then what we'll do is this will be p.keymappings. I think that should work. But if we're calling the OBS handler, then so kind of the way I had this going is the I guess I originally planned for the OBS CMD to actually come through to the display pad worker through the panel. As like a return. But that's all getting sent under the update. So I guess what we could do we can maybe make a command queue or just like a variable to hold our command whenever this is pressed, and then on the next update call it'll return that. Interesting. Okay. Probably not a big deal. I might just do it and then see what kind of problems we run into. Oh yeah. I need to go change our goals. So the OBS WebSocket, we've got change scenes, mute and unmute, alive and unalive. Actually I have not done that one. So we'll take those out. So we still have state management, which is question marks. I don't know if that's a thing that we need to do yet or not. And then display updates. I would like to do partial updates and animations if possible. That's probably going to require some more diving into ghidra to figure out how that's actually occurring on the device. So yeah, let's go ahead and set this up so that the panel returns the value. Okay, so I'm not going to get rid of that because spent time typing it. What we're going to do is self.obs cmd equals and then under the update, we can do if self.obs cmd, then we can return there we go. So we set our status value to what the OBS CMD is, and then we wipe the OBS CMD out, and then we return the status. That way we don't get double firing. So it doesn't keep thinking that we need to send an OBS command and spam it. So then under our display pad worker, if OBS CMD in status, then I think what we want to do is if effectively this. The same thing over here. What did I just do? I'm sorry, did I just close everything on accident? What the dip? Oh, okay. Whatever. Alright. So, I'm gonna come down here, swap all this out. Hit tab. And then let's see if OBS CMD and then toggle input in CMD. Let's see. This is all going to be status 1 because we want the second element in our status tuple. So self OBS handler, blah, blah, blah. Need to change this to not self because we're not referencing self anymore, and it's still called OBS handler. So that should be good. All right, so we'll save this too. Wait, did that not get saved? No, okay, okay. Update self OBS CMD turn status. Okay. So let's go ahead and test this out. Let's see what this does. Let's see. Let's watch it explode. No, we want display pad worker. Oops. Oh, I don't think I have the device attached. We're getting errors though. 46 in main, if OBS CMD and k.action. String object has no attribute get. Oh, okay. Duh. Okay. All right, so let's reference our items. Real quick, let me make sure I have the device passed through to this VM. Yeah, looks like it is. Or just double check. Yep. All right. And let's see what this does. OBS handler is not defined. Oh. Duh. Because I'm not importing it. I'm importing it over here. There we go. It's always the simple stuff. Well, and the hard stuff, but... Alright, so there we go. If self panel object has no attribute, OBS CMD. Line 124, an update under our panel. It's probably because I'm still referencing it as if it exists here. Oh, okay. We need to set up a just stick it up here. Under our actions, self.obs cmd equals none. Just initialize that. All right. And it should go through and load up the default panel. Okay, that's what I'm seeing over here. And if I iterate to the next one, okay. And let's see, what did I set up those buttons for? OBS JSON. So OBS CMD button 3 is going to switch scene. Okay, so that'll switch to scene 1. If I do this, right? Or is it that button? Nice, it's not doing any of them. Oh, that would be why. None-type object. Object is not callable. Line 59 in main, handle input. Let's see. Self actions get. Oh, that's why. I didn't add the OBS CMD to the panels. Let's see. OBS CMD. Self.obs. Reaction OBS CMD. Okay. Just some quick debugging. Okay. Failed to enable with response. Device is not ready for data. I haven't had that in a minute. Okay. Let's go ahead and we'll reset this device. Oops. All right, remove that. I'm just gonna unplug it real quick. All right, plug it back in. Add our host device and LSUSB. Okay. And we'll run this again. See what we get. Operation timed out. Interesting. Now the device is just not playing well. That's always fun. All right, let's try this again. Third time is the charm, right? Hello. Huh. Whack. Wiggity whack. Let's see. Interesting. All right, let's go ahead and restart this VM. Gonna remove the USB device and then just make sure all of our shit is saved. Let's see, I'll save that as U input key maps. All right. Go ahead and close that. Let's restart. Actually, we'll shut it down completely. Shut down. Yep. Okay, and let me turn it back on. All right. Okie dokie. Nice of Kali Linux to bring back up everything I had open. All right, so let's attach our device. Real quick, I'm gonna unplug it. It's going pretty good. Mute Man making some decent progress on it. Almost to the point to where I want to start using it for the stream. Um, but I don't know. I'm one of those people where like I can't ever be done with it. All right, so attach that. There we go. Device booted up this time. Okay, cool. Yeah, I guess it was just not getting passed to the VM properly. All right, so let's go ahead and run our worker again. And hopefully this should work. Oh, cool. New errors. Oh, that's right. I don't have the, should probably fix that. Maybe not. I don't know. All right, so we got our WebSocket password in there. Now it shouldn't complain. All right, there we go. Now it wrote some stuff to the screen. I'm gonna swap over to our OBS one, and then I'm gonna push the third button. Okay, so that's the keybind button. That's the third one, handling input, switching scene. Okay, so let's see if we're on scene one. Nope. Oops. All right, so it says it's running the OBS command, switch scene to scene one, but it's not actually sending it. So what do we fuck up? Display pad worker. Let's see. All right, let's get all these open again. So we've got our display pad worker. This was actually the one that's supposed to be calling the function within our object. So switch scene, running OBS CMD. That's occurring over here, I believe, that print action. So we're gonna run our OBS CMD, self CMD, and then let's see. Yeah, I've been meaning to dive into Rust a little bit more. I want to kind of dig into some of the lower level languages, but I'm I'm such a sucker. I'm spoiled by Python. Python definitely spoils you. So it does look like it's passing it, or at least it should be. Let's just check over here. And let's go ahead and print the status. All right, so let's go ahead and rerun this. And we'll see if it starts reporting properly. I'm gonna go hit my buttons. Oop, wrong one. Okay. So it doesn't actually seem like it's getting, it doesn't seem like the OBS CMD is getting back to the update function over here. I think I had this problem a little bit ago when I was messing with the this thing. All right, let's just see if this is actually getting set a value and if it's getting called. Update called with OBS CMD value. Oh, okay, so wait. No, I'm dumb. It is doing it. It's just not actually calling it to OBS. WebSocket server settings. Do we not have the same password? NZJDJU. That's what I got in there. Yeah. NZDJU. It says we have a connected client. Session duration. Messages in and out. Okay. Interesting. Then I guess my guess I need to go back to the drawing board and look at the OBS integration that I wrote and make sure that that's actually working for changing this scene. So switch scene calls set current program scene with the scene name. Okay. Switch scene, scene 1. Let's see, let's print our data in. And I want to test it on just the OBS integration file. That way we're not constantly pinging the device, hitting the device with stuff that we don't need. So there's an OBS handler, and then we want switch scene to scene 1. Okay. So that swapped it. Why the hell is my other code not doing it then? Switch scene, scene 1. Is it actually even being called? Yeah, I don't think it's actually calling the function over here. Am I stupid? Probably. Answer is probably yes. That's a good question. I probably do need to I shouldn't need to set up a listener because the WebSockets apparently they reply back if there's like a status change or if there's like a response. For example, like this set scene item enabled. Actually, here's a good one. So this one, like get scene item index. This command, if you call it through the WebSocket, it requires these request fields and then it responds with these fields. So if there is a response, it should automatically send it. And then the Python OBS library has some functionality for doing like an event listener. I don't think I need that yet, but I probably will in the future if we get a little bit more complex with it. Because ideally what you'd want to do is over here in the display pad worker, I'd probably want to set up a handle to talk to the OBS WebSocket and then also an event handler that would listen to the OBS WebSocket for events and then respond accordingly. which is what we'd want to do if we started to like get a little bit more fancy with it and like automate things or cause things to happen based on what OBS is reporting. So this should be getting called from here. OBS handler. Let's see. I do want to do this though. If OBS handler, then we can check these. Because that'll probably run into an error or throw an error if we don't have an OBS command in our config, and so it doesn't initialize the handler. So we set that up. OBS integration, OBS handler. Oh, do I need to call get? No, because it calls get OBS handle for itself on init. It sets up the scenes. Okay. Gets the password from the WebSocket, or gets the password for the WebSocket from the environment variable. Hmm. And we weren't getting the OBS CMD, right? Update called with OBS CMD value. Let's just try this. We'll do, no, wait. You want, oh, is that what it is? I'm sending the, let's get the config open real quick. So the value is going to be switch underscore scene, scene1. Switch scene, okay. Sorry, I'm getting lost in my own code. Status self OBS CMD, update called with OBS CMD value, return OBS CMD. Let's see. Oh, okay. That's what we need to do. We need to just name these a little bit better. Okay, so that should pass the, so that's the CMD and the parameters. It gives us a tuple within a tuple. So then over here, status 0, and then let's see, let's just set up a OBS CMD equals status. We'll denest this real quick. So the second element in OBS CMD is going to be the parameters. The first one is going to be that one right there. And let's swap these out. Oh, Jesus. OBS CMD. All right, cool. So this will go and parse our status. I think that looks right. It's very ugly and confusing, but whatever. Go ahead and rerun this. This should go through, set up the device again, connect to OBS. And then let's see if we go to scene 2, push the button, nothing. Yeah, name params is not defined. Yeah, it's ugly and gross because I did it ugly and gross. Rookie mistake. Okay. In switch scene. I didn't switch it though. OBS CMD switch scene in switch scene. Oh, W is the So this is our in switch scene. It prints out the name, so why is it passing just a W? Oh. There we go. Because we're accessing the wrong thing. Alright, third time is the charm, right? Let's see if this works. Hey, look at that. Okay, so this only just switches. It doesn't toggle back and forth, but if I push the button, we can see it swaps the scene now. Cool. Alright. So that's good. And then what about muting the microphone? Wait, which one is that? That's this one? That one. There we go. Hey, mic mute works. Nice. Cool. Alright. So what I can do now, toggling input mic, there's a bunch of freaking print statements that I need to clean up. Debug statements, as I call them. Okay. So that's working now. One of the other things that I wanted to do was set up the feedback loop between the responses that OBS sends. So like our OBS integration, let's see, I think that toggle input was the main one. So this one will return the response of toggle input. So if we go back into displayPad worker and we do, let's see, let's just print the output of the toggle input. Let's see what that gives us. We should be able to respond appropriately or react differently depending on what the depending on if the input is muted or not. Then we can write some code to like change the icon to something different or change the color of it to something different. So, oh, wrong one. Yeah, so input muted true, input muted false. Okay. Let's make sure that lines up. So input muted false, input muted true. Okay, cool. Yeah, so this is our feedback loop. It's taking the response from the WebSocket server. And we're getting that all the way back into our worker. So if we want, what we can do is we can handle that over here. And I guess we'd have to write some code to like toggle an icon or something. Or I guess we could just call set an icon again. Yeah, I think that's a project for another day, probably. So we've got that mostly working. I think what I want to do now, what are my other goals? Oh yeah, the live and unalive. So we gotta hook up the start and stop for the OBS handler for like stopping and starting recording. So let's go and do that. Toggle record. Toggles the status of the record output. So let's go ahead and make our boiler code, boilerplate. This is all nested poorly. There we go. So what we'll want to do is steal some of our code. Okay. Do, 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 do. Okay, so I'm gonna call a request toggle. What was it? Toggle record. Do we need any params for it? Nope. No parameters, and our response is output active. All right, so that should be good now. And if we go to here, we can do a toggle record. Then if we set up in our config, actually wanted to move this because it was in the wrong one. And then let's set this one to, actually we'll do the very last one. OBS CMD, and we want to set it to toggle record. And that might actually throw us an error because we're trying to split this on spaces and then get the second one. So like if we go into our panel and come down here, we can see that we're splitting this. So if we don't have a space in there, it's probably going to throw an error when we try to assign this params value. But we'll see. So what do we want the icon for this one to be? Go into panels, assets, and I think there's a, is there a typical record icon? No. Do the circle, circle.png. Okay. So come over here now, reload this. It's going to throw an error. No? Okay. All right. Let's see what this does. Nope. No, no, no. Hey, there it is. There's the error. See, I told you. Told you it was going to throw an error. So I guess what we need to do is check. We need to check to see if our command is one thing or not. Let's see if in, let's see. I don't know. Because what we want to do is we want to handle this appropriately before it gets to here, I think. So we're kind of expecting a tuple of parameters. I guess it doesn't really matter because it's just going to throw it off as long as we set this up appropriately. It should be fine. Lazy for sure, but so lazy I'm leaving my colons. All right. All right, there we go. Hey, look, it's recording. And we can stop recording. And we can start recording. And we can stop recording. Hey, what's up, Baba? Welcome to the stream. How are you doing? All right, cool. So we got that going. So I guess our OBS WebSocket is done unless we have some more ideas for it. Actually, I do. As mentioned earlier by Muteman, I believe, event handler. So let's go ahead and do that. So we can make an event handler for OBS WebSockets. Let's check out. Oops. Let's see what the events are. See if there's anything interesting in here that we want to grab. Events. Yeah, you can get real crazy with this apparently. Yeah, imagine if you were if you're somebody like Doug who does a lot of like Twitch integrations. If you had like OBS WebSockets hooked up with your Twitch integration, you could get some really rowdy stuff going on. Let's see. Got scene events, output events, media events, UI. None of it seems super useful, but we can just set it up. And then if we want to, we can hook into it later. Or is that going too far? I don't know. What time is it? Been going for about an hour. I think I'm gonna take a quick break, about 5 minutes. I'm gonna go get some more coffee, and I will be back. So I'm gonna put you guys in the idle room with some cool music. So hang tight, and I'll see you guys in just a minute. Yo, what up? Okay, I'm back. Got some fresh coffee. Delicious bean water. All right, so we were thinking about hooking up an event listener. And I think the best way to do that would be to might be ideal to set that up in here, and then within our display pad worker, kind of listen to it during the while loop. So we can check for panel updates, then we can check for OBS updates, and then do stuff. So let's see. Our OBS integration. How do we set up a event listener? There was another page that had some examples. If I can find it. I think which one was it? I think it was over here. How does the fake deck communicate with the PC, and how does it send big stuff like images? So it's actually communicating over USB. And I've got this whole library that I wrote that basically emulates all of the USB messages, and it sends them through the Python USB core library. So we're doing interrupt in and interrupt out messages to the device. So there's a lot of crap in here that is not cleaned up. I do want to publish this code to Git pretty soon, so I'll probably go through here and clean some of this stuff up and add some more comments, make it a little bit more easy to look at, and then post it up on Git for people to dig through and do whatever the hell they want to. But this is the meat of it right here, how the device is actually communicating with the PC. We've got our interrupt in and our interrupt out functions, and these basically send USB interrupt messages. And the device expects messages that are 1024 bytes in size. So we basically set up a 1024 byte array, and then we stick these headers at the front, which are these little guys. We set these header values at the front of that 1024 byte message, and then we stack our data into those messages. The pictures themselves, those are a little bit more complicated. That took me a bit longer to figure out, but the function that I'm running to do that is this get GG set panel image, and what this will do is it'll go through and get all of the RGB pixel values of the image, and it'll stuff that into a huge array of data that's 5,000 or 576,000 bytes large. I think, or I'm sorry, that's the resolution of it, the full pixel resolution. So we're sending 576,000 pixels, I believe, and each one of those is an RGB value. So we take all of those RGB values and we stack them into a bunch of 1024 byte messages, and we send all of those in a row. So we basically tell the device right here as we're sending it the first interrupt out message for, hey, I'm going to send you an image. And then when it responds and it says, okay, I'm ready, it'll respond with this value. And then if it responds with that value, then we go and we send the rest of the image. We'll send, those dozens of 1024 byte messages. And I have and I can show you over here in Windows a little bit more about it. So in Wireshark, I'll show you the messages themselves, because this device doesn't have drivers in Linux. It only works in Windows. So what I did is I basically set the device up in Windows with their own software, and I used Wireshark to capture the USB data. Don't know. Oh, it's installed on my portable one. Yeah, this is a project that I've been working on for a while. How to crack randomization in-game crates. What does that mean? Come on, Wireshark, you can do it. If you want to crack randomization in game crates, I think your best shot is to try to reverse engineer the binary and see if those values are actually in the binary anywhere. I doubt it. I'd imagine most of that stuff is all server side. But depending on the game, I mean, all games are different. So some companies may have it so that the actual odds for the crate are stored in the binary, and so when you go and you open a crate in the game, it just goes and references its own, in-memory data and says, hey, this is the odds of, what you're gonna get. But I would imagine that most games nowadays that have like loot boxes and gotcha elements are going to do all of that server side, where when you click on, hey, I want to open this crate, your game basically just sends a request to their server and says, hey, I'm opening this crate. And then the server says, okay, you've got that crate, you got the key, you're going to open it, let's go roll the odds on the server, and then it'll respond back with what you actually got. So chances are it's going to be server side, but I would recommend checking out the game binary. That might actually, give you some ideas on what's going on. You can also fire up Wireshark while you're playing the game and when you open a crate. And if they don't use like TLS for their network, you should be able to see that. Let's see. So these are I'm just gonna open up an old Wireshark capture. So these are like key presses. We can see at the beginning our device, or our host right here. You can see the source of the message is host. The destination is going to this USB device 1.2.4. And we can see that over here in the leftover capture data, this is all the information that's being passed back and forth that's not protocol information. So this is the juicy stuff. And we can see this this starts with 1180. This is actually kind of like a setup command that the device does. So it goes through and asks for some information, and then the device will respond, hey, I'm ready. And then the PC will send some information. So you can see this request right here. It looks like the host sends out 19 and then some other values, and then the device responds with what looks like a GUID, or a globally unique ID. So that's an interesting function. So yeah, I basically just went through and captured a bunch of data from the device while I was pushing all the buttons and making it do things with their own software. And then I got to the point where I could emulate that. It took a little bit of reverse engineering their own binaries with ghidra. And they also have some fun stuff with, let's see, do I have it installed? Yeah, ILSpy, okay. Some of their application is actually written in C#, which makes it real easy to reverse. I wouldn't say real easy, but easier. For example, this is the set panel image that I was referring to earlier that I'm emulating with my own code, and the tools that they provide, the drivers that they provide, some of that's written in C#, so I can see where it's actually calling the DLL functions under this DisplayPad SDK, and it's calling those with some certain values. So that's kind of like my starting point for digging into this is getting a hold of this, like these function calls, and then going into the DLL and actually trying to figure out what it's doing when it sends that data to the device. But ultimately, it results in sending those 1024 byte messages over USB. Yeah, reversing your keyboard RGB. That's that's a big one. A lot of times like keyboards and just peripheral manufacturers just have very crappy driver support. But it is fun. I like Wireshark a lot. Just being able to like see the information that's flowing over the wire is very nice. Provide it can provide a lot of good starting points for a lot of analysis. Let's see. I got the okay. So I have our event handler. I still don't know how to actually make the how to actually call the Let's see. Python OBS WebSocket. There were some examples. I think it was under this dude's. Or is it under the docs? Is it under the docs? Or PyPy? Ah, this one. I think it was this one. Oh, but this is a different library. That's why I was having issues with it. I guess that makes sense. Duh. Okay. Hmm. Any examples? Give me examples. Nothing. 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 Okay. I hate digging for docs. It's my least favorite thing. I mean, I've got this, but it doesn't exactly tell you how to, event subscription? Subscription value, use to disable all events. I guess we could just explore the Python itself. Let's see. And then let's do print dir obs ws. See what we got. Call, connect, disconnect, reconnect, register, unregister. Let's see. Oh, maybe I'm just blind. Okay, here we go. Let's read through this. Connection notes, creating an authentication string. Opcodes. Okay. Identify opcode. Event opcode 5. Sent from OBS WebSocket. Okay, so I think what I need to do is, because once we've established the handle in our Python code, like once we've done this or get OBS handle and returns WS, I think we just need to listen to this um, for messages, maybe. Let's go back over to here. And we will just do this. Make sure we're in the right nest. Okay. If OBS handler, oops, cannot type. Let's see what that does. I am not expecting that to actually result in much, but I'm expecting it to just constantly print out a bunch of stuff. Yeah, there we go. And then if we go and we push a button for OBS, yeah, maybe we just need to like get the messages from it or something. Let's see what the OBS handler object is. Oh, good God. Okay. Enumerations, events. Okay, so let's just read through this. Stop being lazy. Initial HTTP connection requests made to the WebSocket server. Once the connection is upgraded, the WebSocket server will immediately send an opcode 0. Client listens for the hello, responds with an identify containing all appropriate session parameters. Server receives and processes identify sent by the client. If authentication is required, identify message does not contain the string. Once identification is processed on the server responds to the client with opcode 2. Client begins receiving events from the OBS WebSocket, may now make requests to OBS WebSocket. At any time after a client has been identified, it may send an opcode 3 to re-identify. Okay. Let's see, is this, I'm just gonna throw a caution to the wind. I think we might be able to do the .data in from that. No, okay, has no attribute data in. Okay. Good old debug Python. Nice. Okay. I don't need all that all the time. Get OBS handle, get scenes. Oh. Dot handle, right? Oops. I'm sitting here referencing my own freaking object. OBS handler, printer, OBS handle. Okay. If you guys haven't figured it out yet, I have no clue what I'm doing. Okay, so we have an events value. Event manager, disconnect, call, okay. Let's just print the events then. Let's see what that is. Okay, so that's going to print out a bunch of nothing. And then if I go into OBS and I do like start recording. No, stop recording. What about? No. Okay. I have no idea what the event manager is. Oh, that's because this isn't the Python library, is it? Um, because this is the actual WebSocket module, right? This is the code for the WebSocket module. And I'm sitting here trying to talk to the Python library. OBS project, OBS WebSocket, where is... I can't even remember the damn library that I'm using. Okay. No, that's not the library that I'm using. What the... Da, da, da. Okay, so it's this one. Here are our samples. Make a call. Register, unregister. Do do do. Here we go. I just steal some code from here. All right, so on event message imports events. OBS WebSocket registers on switch. Okay, so you register on switch or on event. Okay. So we need to make a OBS on event function. Actually, I'll just print real quick. Print. Root. Handling OBS event. And then what we can do in here is set up our OBS handler.handle.register. And then how did they do that? On event. So you just register on event, and then on switch, you can register with a particular... Okay, so if you want to register a function with any event, you can just do this. If you want to register a function with certain events, you can do that. So that's kind of neat. Let's go ahead and do this over here. Just want to see what it looks like first. Oh no, wait, because we're getting the handle over here. So we'll put it in the integration. So this will, if WS, then we do WS.register self dot event. Wait, handle event. Handle event. Right? Yes. So then we should get it screaming about stuff all the time. Or screaming about errors. We'll see. Alright, so it's working. I can swap screens. What does this do if I... Ooh, look at that. Handling OBS event. Cool. Alright, cool. Oh. Is that why? Register yourself, handle it. No, I got that right. Then on event just gets a message. I wonder if I need to take this. It doesn't like it because it's a method. Oops. Let's try that. We'll see what that does. See if it actually spits out what the contents of the message is. Because before it was not, so I don't think it was calling it properly. OBS handler object has no handle event. Oh, duh. Okay. And then if I go into OBS and do something, well, it gets that it's doing stuff in OBS, but I'm not getting the message back. Hmm. OBS ws.register on event. Huh. Let's see if we can... Oh, I'm so stupid. I do this all the damn time. It's because I'm not actually freaking formatting the string. God, I'm such an idiot. Okay. Do, 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 do. Wow, look at that. Wow. Okay, cool. So we have an event handler. What we want to do with that, I have no clue. I don't really have any ideas of what we should set up the event handler to do yet. But I think I want to go through here and start cleaning up some of the code and doing some of the config to actually start using the device, because the whole point in me doing this is so that I can use the device, because I have other things that I want to reverse engineer that I want to start working on, but this thing is too practical to not get working. So let's go ahead and clean up some of this code. First off, don't need any of that. Actually, before we start doing any of this, let's go ahead and git status, git add, and commit. What do we do? What do we do? Added record, toggle record. Created basic event listener. Yeah, that's good enough. All right, so git push gut push. And we will push this to git. All right, cool. Okay, so now if I fuck shit up, I have a waypoint to go back to, which is always useful. If you're ever messing with code, you should learn how to use git, because git is very nice. It is very useful. Okay, so let's start with the mountain display pad, because I want to come through here and actually start adding some more, because I would like to have it have our config handle some other functionality of the device, like setting like the timeout. Yeah, setting the screen timeout. I think there was another one. Yeah, I wanted to get the device information, like the device version. I don't know why. Just thought it would be fun. Okay. And then I also wanted to mess with this a little bit more too, the read sector memory. Because I wanted to try and dump all the memory off the device, but it was very picky. And then I had these other functions that I was working on, like the set FW info, set firmware info, or sorry, get firmware info, and then set the main brightness to change the brightness of the display. That one would be kind of nice to actually get working. Yeah, let's play with that. I don't know. Kind of open-ended. You guys have any suggestions? Anything that you want to see in particular? Because I can clean this up and throw it on Git, and then start working on the config so that I can use it. Or we can dig into some of the other functionality of the device, like setting the brightness of it, getting some firmware information from it, doing some more of the actual like hardware side of the reverse engineering as opposed to the software. AP enabled. Yeah, and there's still some questions that I'm not too sure about with the device as well, like why it needs this AP enable command sent to it. What other functionality? So like if we go into Windows, there's like a buttload of functionality in here. Let's see our references. No, what do I want? Can't remember where it's at. Is it under here? No. Hey, OBS WebSocket.net. So I wonder if they're doing the same thing, if they're not even like sending hotkeys, they're just doing the WebSocket. That's probably better anyway. No. Derived types, base types, no. What am I looking for? Oh, I don't have the files on here. Oh, okay. 1 second. I've got to get a disk hooked up to this VM. I guess I could just download it. I think I already have the files on here. Yeah, Mountain Base Camp. See, I already got it. Okay. I don't think that's it. That's not what I wanted. There it is, Mount Display Pad Worker. Bruh. Let's just do Control F. Will that work? Where is this at? Nested under DisplayPad SDK. Oh, okay. No wonder I didn't find it. Okay. So we want to mess with the brightness, right? Let's see, get main brightness. So there's a get main brightness function that they call within the DLL. And they reference by brightness convert, and that's the device ID. Okay. And then if we go into ghidra, let's dig into some of the lower level stuff. This will take a minute to run. I don't remember if I've got a function for the brightness yet. I think I had this one and I kind of set main brightness, but I don't have get main brightness, I don't think. No, so we'll probably want that. And then I did get main brightness and set main brightness are these two header values. So I've already got that going, which is cool. I think I need to put this into an array. Okay, looks like ghidra's up. All right, and then DisplayPad SDK. Probably put some more cores on this VM. Or is it memory? What do we need? What do we need? I was like barely doing anything. Oh, it's the disk. Wow, that thing is slow. What the dip, yo? Oh, I should fix that. Okay, why did this not open with anything? Oh, it's still going. There we go. All right, so our exports, we are interested in setting and getting the brightness. So we've got get main brightness. Let's work on this one first. So in our decompiled view, and I've already got some stuff kind of renamed in here. So looks like we're checking some offsets within the device table. I believe that is to get the handle of the device. And then this is the actual calling in the function. So let's rename this to actually get main brightness. All right, and then parameter 1 is, so we know by the IL spy. Let's go for let's analyze that used by. Get main brightness right here. So this is a byte by brightness and then an integer ID. So let's go ahead and change that. Oh, see, retype the variable. We want to change this to a byte. And we want a byte pointer. Okay. And that's by brightness. Oh, I cannot type by brightness. Okay. And then this one is going to be device ID. So ID. So we call get main brightness and we pass it our by brightness value. So let's go ahead and go into that. And let's retype this again. That's going to be byte pointer. And then it's going to be by brightness. So that's a 1 byte brightness value. Imagine that goes up to 255 or something. All right, so this is the function for actually sending the message to the device. So the message that it's sending is some of this stuff. So our local 50, that's going to be our message. So we go back and look at this, we can see that it's a lot of nonsense really, but we've got 1 byte value at the very beginning, which is 18 or 0x12. And let's make sure, and local 4e, not sure where that's actually getting stacked up. mset message 0. What is that at symbol? Okay, I think. So I'm gonna go and I look at my what we could do is we can emulate the device or run the device over here, capture that data and cross-check it. So let's go ahead and do that. So I want to I'll close out of that. I want to get a new USB PCAP. Capture from newly connected devices, inject, okay. Start. So that's going to look for newly connected devices. I'm going to go ahead and unplug the device, and then I'm going to pass it through to this virtual machine, the Windows one. So come down here, and you guys can't see this because it's off display, but I'm just going into libvirt. And we'll add that, and you can see Wireshark starts spitting out a bunch of garbage. We don't have our leftover capture data because it is under a different one. Is it data? No. Probably HID data. Yep, there we go. HID data. So let's go ahead and let's open our display pad worker. And we'll go ahead and set the brightness and a couple other things and see what that does. On Basecamp. Run our basecamp.exe. And we should start to see a bunch of crap go across our screen. Yep. So this is the ones that start with this 118. That's the AP enable command. All right. And let's see, can I clear this? Capture. No. Okay. Okay. Just to clear that up, let's go ahead and go into customize. And actually, I want to do that again. Let's see. Settings. There we go. So there's our brightness slider. Let's go ahead and change this to 3764. Just to make it a little bit clearer. And then we'll come in here and we'll set the brightness value to something else. And then we can see over USB that we sent this packet that has this HID data. Vendor data is 12, and then this is the padding. Okay, so in ghidra, come over here, and this looks a little bit familiar. We've got our vendor data, 12. And we've got some other crap in there. Got a 03, and then some other stuff. 000, and then a 64. Okay, so that's 32 bytes of data that it's sending in the actual packet. Where's this 100 coming from? Or where is it going? Is that the max value maybe? But if we set the brightness all the way down to here. 1203, so the message is the same roughly, except it's missing the 64 at the end. So maybe that's the only value that's changing. Set it up a little. It's got a 19. Yeah, so it seems like that's the only value that keeps changing. There's the 03. So our vendor data is the 12, and then we have a 03, and then we have where is that at? Okay. Let me do it again. And then this gives us 32, so that's like half of 64. That's halfway. So it looks like 64 is like the max value for brightness, and then this slider is kind of just going in between those values. So if we want to, I'm going to write our own function for it. we can do that. This is Wireshark Rover. Wireshark can actually capture USB. There's a library called libusb pcap or libusb cap, and that'll give you access in Windows to capture USB messages. So you can see these are USB or URB interrupt in and out messages going to the device. And you can use the same and similar filters that you use for Wireshark too, so if you're really familiar with that, that would come in handy. So it looks like for that function, should be pretty straightforward. Let's go back into Linux where we are working on the code. And so this is our set main brightness 0312. Nice, nice. Yeah, keep at it. You get better and better the more you do it. You learn new stuff every single time you try it. So our function, I believe we had a brightness function down here. This is our set main brightness. The value. So what I was doing with this one, and this might be out of date because I've gone through and changed these functions multiple times. We may not need to prep the message, but let's check. Yeah, I don't think I do because I incorporated all of that into the interrupt functions. Or no, wait. Message, structure pack, message, okay. Okay. So we get the header from the commands. Okie dokie. It's been a minute since I've dug into this code, so I'm going to have to spend a little bit of time catching up to how I was actually writing all of this. So get the header from our command. Let's see. And then we want to set our value. So our header is going to be that 0312, right? It's going to be this right here. It's going to show up as 03. Sorry, 1203 in our actual USB, or at least what gets sent to the device. And then over here we want to got our header, interrupt out. Ugh, this is a mess. So for these, I am just straight up sending to the interrupt out function the actual endpoint and then the message. Okay. But we are building the structure or building the message because that is very specific to the function. So we want to do that. That's what we need to do. We need to make our message and then we need to send that to it. Okay. So let's do message equals struct.pack. We want to pack these little endian, and then I have an integer, 2 integers, which is our message. Or sorry, our header. I think that's right. Let's make sure. All right. Yeah, I think that should work. Okay, so let's just do that. And then our message is going to be that. because that's already an array. And then let's go ahead and comment that out. We want to $equals self.interrupt out for comma message. And then we have if r print self underscore interrupt in. And then what do we want for that? For 64, I think. I don't think we need to call it. It'll automatically do that. So let's just print our R as hex. All right. And then let's go ahead and get the device back over to Linux. All right, remove that. And then we go into out of hardware, USB device. Okay, and then ls USB. All right, so we've got our device there. And then what I want to do is over here, I'm just going to short circuit this real quick because I don't want to go through and make the thing run as a loop. So I just want to test it real quick. So we're going to do device dot set gg set main brightness. And we want to pass, I think D results in 64, I think. Let's see, we're going to want to pack that onto the end. So let's go back into Windows real quick. If we go into ghidra, yeah, 256 I think is the max value. That doesn't make any sense. Oh. So there's our by brightness. Is that one the local 54? Oh, here's what I need is the concat. See how it's concatenating these messages together. B stack 4B. Yeah, I have no clue what any of this is or what it's trying to do. So let's just throw some shit at it and see what it does. So I think we need a I don't know what the padding is. That's the one that's throwing me off. Let's see, back into Windows. So this padding right here between the 1203 and then the actual value is 2 bytes. And then there's the third byte. And if we look at this, this is 3 bytes concatenated with 1 byte. Hey, you too, Rover. Take care. So we're concatenating 3 bytes and 1 byte for 4 bytes total. So I think really what I need to do, I don't know what the 64 has to do with anything though. Or why all of these had the 3 in them. Oh, this is get main brightness, not set main brightness. What am I doing? That would make more sense if I go into the right damn function. Okay, so set main brightness. So 0x12, okay. So that's our message. And then we can cat all that shit onto it. If by brightness is not equal to 0, then local force C is by brightness. If by brightness is not equal to 0, oh, okay. So it defaults by setting the, so it starts up, sets a value to 0. Let's see, let's rename this. I'm not sure what this is for, this 03. Oops. It's just like a static value. It just gets appended to it. Oh, is that because the get panel brightness or whatever, get main brightness starts with 1, 2 as well? And the 03 is to just specify, hey, yeah, I think that's what it is. Okay. Byte is by brightness, and then it is a length 1 byte, unsigned byte. Okay. Let's go back into Linux. And let's see. Thanks for the sub, Veritas. Let's go to Python struct. I always forget how to do this, what the syntax is, so pull up some docs. All right, so little endian, and then I think I should be able to just use integers. Let's see. standard size of 1, integer, standard size of 4. Okay, so that just needs to be a character over here. So let's see, this first one, the message needs to be integer. You want another integer, and then that is going to be, actually let's just rename this. Header, and then message equals header, and then it's going to be value. And because I don't actually want to send that to the device yet, let's go ahead and do that. Come over here. And we'll set the main brightness to that. And just print out what the message looks like. And we'll make sure that it looks similar to what we were seeing in Wireshark. So I'm going to go ahead and unplug this device. Actually, it says it's still good, right? Let's see if it winds or not. Pack expected 2 items for packing, got 1. Oh. Right? Is that what I gotta do? Yeah, that's what I was doing over here, is unpacking it. Kind of counterproductive, but whatever. Wired argument is not an integer. Ah, but which one? It's probably this one. Let's do ord. And get the actual byte value for that character. No? Required argument is not an integer. I'm probably doing this all wrong. But whatever. Oh, that's why. Alright, 1203 and then 00064. Does that look right? So in our Wandos, we have 4 zeros and then our last byte. Okay, yeah, I think that seems right. So then we can come over here, back to Linux, go back to Linux. And now that we're creating and packing that message properly, we can send that out. So let's go ahead and send that to the device. And then let's set the value to 0, just to see if we can turn off the display. Or 32, we could try 32. Actually, I want to change this. I don't like the way that works. Value equals 64. And then what we can do is some more logic over here. I want to move this down to where we actually send it to the device. And then up here, we can do if value is greater than 64, value equals 64. And this is going to be very similar to the code that's actually in ghidra. because that's what they, it's the same thing that they're doing. So we're going to cap our value at 64 because that is the most. And we could translate that if we had like a sliding scale. Can make it so that 100 equals 64. So that would be the equivalent of like taking 64 and then multiplying it by the difference in 100 to get like the percentage difference. But that's too much work, so we will do this for now. We don't need to convert that from an ord because it's just a number. All right, and then let's send this just to make sure. Sanity check. Yep, there we go. And then how are we printing the response from this? I think we were just getting the response. Self-interrupt out. Okay, cool. So I don't even think we need to do this anymore because we're handling that over in our interrupt out function. Okay. So now if everything works, it should set the brightness to nothing because, or it should set the brightness to max. Let's see, localhost, generate 8 bytes to endpoint 4. And then it says 1203000 and then 40. Oh, 4. Up. So let's go ahead and call it with value equals 0. And we'll just see if we can turn it off. Turn off the display. All right, cool. Yeah, so that turned the display off. I don't know if you guys can see this. I'll see if I can get the camera. So it got turned off on us. And then if I go and set the value to 64 again, oops, 64, and save that, and then we rerun it, this should pop up. Or not. See, it's not writing the 64 properly. Okay. So we can write a 0 properly, but not a 64. What is that under? Right over here. Interesting. Is 255 do it? Is 255 gonna do it for me? No, okay, so that's spit the same thing out. Oh, I'm so dumb. Interesting. Oh, it's because I'm over here setting the thing. Let's just play with the default value so I don't have to go back and forth 20 different times. So that's FF. Okay. Interesting. All right. Let's see. Where are we at? Been going for 2.5 hours. It's usually where I tend to tap out. So I think this about wraps it up for today. We got some progress. We got some decent progress on the thing. Fixed up our OBS integration and got that working from the device. So next time you see me, I'll probably have this hooked up to the actual stream, maybe with a config. I don't know. But I do want to dig into like these functions a little bit more and maybe get these working so that we can specify like brightness through the config values. And then maybe mess around with like reading the sector memory just because that's some interesting stuff to do. But overall, I think I'm wrapping up this device. I do have some other things on the table that I want to dig into and kind of figure out how they work. For instance, my sister got me these little tracking tiles, and they have like they're meant to be like some blockchain tracking bullshit, and I want to take them apart and figure out how those work and see if we can get some details about how those are actually functioning and what type of protocol they operate on, you know, what type of wireless mechanisms they're using to send and receive data and that kind of stuff. And they've also got some larger pieces of hardware that I could dig into that would be kind of fun. Yeah. I hope you guys learned something, and if you enjoyed that, you know what to do. But I tend to stream every Tuesday and Thursday at 3 p.m. Central. So if you like that and you want to catch me again, that's usually when I'll be on. But yeah, hope you guys have a great rest of your day. All right, take care. Bye.